In this lab, we're going to be determining the concentration of an unknown sample, and in this lab specifically our sample is going to be sodium hydroxide, so a base. To determine the unknown concentration, we are actually going to use a titrant and perform a titration. Now for this lab, our titration is going to be 0.894 moles per liter of hydrochloric acid, so 0.894 moles per liter of hydrochloric acid. Okay, so make sure to record that into your data tables. And like I said, the sodium hydroxide is actually going to be an unknown, and we will be using stoichiometry to calculate that concentration after the titration reaches the equivalence point. Now it is important in a titration to understand those terms such as equivalence point and end point. For our titration, we will be using an indicator called bromothymol blue for our end point. The end point in the acid-base titration is a color change, and the color change indicates at the point where the sample, which is our base, and our titrant, which is our acid, have completely reacted in their mole ratio. So for this lab, being the acid and the base, we will have a neutralization reaction and we'll have water. And for bromothymol blue, when it is in neutral water, it has a green color. In a base, it has a blue color, and in an acid, it has a yellow color. So bromothymol blue is a great indicator to indicate our endpoint because it is a different color than both the base and acid forms. Once you reach the endpoint, what that does is that gives us a reason to stop and measure the volume inside the burette. And the volume in the burette is going to indicate the equivalence volume, or the amount of acid that it took to react fully with the sample. Once we have the equivalence volume, we go ahead and start the calculations for moles. Now to begin, we need to rinse out our burette. Not sure if there's dust that is accumulated in the burette or what might be the case. So we'll take a wash bottle and simply squirt some water into the top of the burette and allow it to drain into a waste beaker. You'll notice here that the burette has a stopcock to operate the flow, and when it is in its parallel position, the solution in the burette can flow out. When the stopcock is placed into a perpendicular position, the fluid in the burette will stop. Okay? In titration, that means that you need two hands in order to perform a successful titration. One to continuously operate the stopcock to change the flow rate, and the other one to be swirling the flask where the sample and the titrant are mixing. In my case, because I'm right-handed, I tend to use my right hand to swirl the flask because I have more control, and I use my left hand to operate the stopcock. So when I set up my burette, I make sure to get it in the position that I want. I tighten the clamps on the burette so that it can't fall and damage the tip, and then we're ready to titrate. We have rinsed with water, but unfortunately if I went ahead now and filled this with acid and then titrated, the first bit of acid is going to be diluted from the water that's left in the burette. So before we do that, we need a rinse with our titrant, which is our acid, and I'll use a tiny little funnel here, a burette funnel, and place it in the top of the burette, and we'll fill it with a little bit of acid to do a rinse. In Chemistry 30, you'll go through a few more specific steps to rinse your burette. However, in Chemistry 20, there is an expectation that you begin the skills of titration, and they will be expanded on and mastered in Chemistry 30. So now that we've poured a little bit of acid into the burette, we can see that there is a slight volume of acid in the burette there. We're going to run that acid straight into the waste beaker because that acid is not going to be used for our titration, as it has been slightly diluted with the water inside the burette. We have 3 Erlenmeyer flasks here which will be used to perform our titration. They have been cleaned and dried and ready for our reaction. It's important to be able to reach the stopcock in the flask in order to titrate. So we'll bring this down here. And what's really important is the ability to measure the volume inside the burette using the meniscus. Now while that's draining, we'll measure out a 10 milliliter sample of our sodium hydroxide and demonstrate the meniscus measurement in our graduated cylinder. So 10 milliliters in a graduated cylinder should be measured to the bottom of the meniscus line. So the meniscus occurs because water has adhesive properties to other substances such as glass. And what that means is that inside the graduated cylinder or inside of a burette, for example, water will adhere to the sides and be slightly higher than it is in the center. So I'll use an eyedropper to remove any of the excess and bring my meniscus line down to the 10 milliliter mark. And I'll put the excess base into my waste beaker. And then we'll take a second here to actually zoom the camera into the meniscus. But in order to do this, we actually need the camera to be level with the line inside the graduated cylinder. If the camera is not level, an error occurs called parallax, where the front line and the back line are not perfectly aligned. And if the front and back lines are not perfectly aligned, we wouldn't observe this small little difference here. So we can see that the bubble is slightly above the zero line. So we'll use our eyedropper to take out the tiniest bit of volume. And then add just a little bit to get the meniscus back to the line. So now we can see the bottom of the bubble is just touching the line, and that means that it is exactly 10 milliliters. For the purposes of this titration, it's a little easier to place a piece of white paper so that the color change for the endpoint is a little bit more apparent. We also need to now make sure that the stopcock is in the closed position perpendicular to the burette, and we will fill up the burette with our titrant, being our 0.894 moles per liter hydrochloric acid. Now for this lab, as it is an online lab, students will be expected to record volumes off of a burette. So I will take the camera and zoom in on the volume that is now considered the initial volume for this first titration, and you will record that into your data book. For this first reading, I'll help by explaining the 2 milliliter mark is above and the 3 milliliter mark is below. And this is because burettes are basically a graduated cylinder that's upside down. So we're actually increasing volume as we go down the tube because that is the amount of volume added into the sample. The difficulty in titration is it is a two-handed process, with my left hand in this case operating the stopcock to control the flow, and my right hand swirling all the time in order to mix my two reactants. I'm using 3 fingers to do that. 2 fingers grasping the neck there, and my third finger is actually providing the swirling motion. And we want just a drip at a time, very, very slow, because the color change could occur with just a single drop of titrant, and we don't know exactly how much titrant that will be. What might be difficult to observe in the camera is the color change that occurs when the drop lands. Where the drop lands, it does turn slightly yellow, but the color fades very quickly. And this is due to the fact that at this point there's excess sample in a very limited amount of titrant, so we aren't getting our neutralization occurring quite yet, and instead the titrant is immediately reacted and we're left with lots of excess sample still, which is that blue color. We'll try and make a faster drip rate here. It's important to be watching the color change very carefully. If the color change, or if the fading of the color change is occurring slowly, that indicates that we're getting closer to our equivalence point and closer to our end point, which is a color that's green. we can see that the color is still blue. I'm dripping into the center just to show the yellow, and then as I swirl, that yellow fades. So the color change going from that yellow and then fading away to blue, and in this case it didn't fade and the yellow stayed, and this would be considered an overshoot because I've actually passed the green point, and I will record the volume, but this volume will give me an indication of how much I need in order to reach my endpoint. Now we can see there is a small drop hanging off the tip. That actually must be included by a small squirt from a wash bottle because that has actually left the burette already. It must be counted as volume. So now we have a color that is yellow, and that is going to be considered our overshoot. We will again take the camera and zoom in on the... And what we can see in this volume is between the 8 and the 9 milliliter mark, there's a larger line that goes all the way across, which is the 8.5 milliliter mark. And we can see the bubble is not quite at that line. While it is slightly past the 8.4 milliliter mark, in our class in Chemistry 20, we don't get into subdividing the smaller gradients into pieces, and so we can record this volume as 8.4 milliliters. My second titration will be adding in at a relatively fast rate about 6 milliliters or perhaps 5.5 milliliters, and then slowly dripping in the last portion to get the color change at endpoint. In this way we can perform several trials at a quicker pace with, of course, the goal to be 3 trials within 0.1 milliliters. So once again we will start with a 10 milliliter sample measuring the meniscus. We will add in our indicator. The blue color. We will get our flask over top of our burette. And we'll zoom in this case to see the color change perhaps a little bit better. So in this case, like I said, we will be adding in roughly 6 milliliters at a relatively quick rate. So we're getting up to the 5 milliliter mark. And our color is still blue. Now at this point we'll slow it down and add just a drop at a time, attempting to reach that perfect endpoint of green. While it may be slow to reach endpoint with only one drop, the idea in titration is to have a single drop change the entire color, which indicates the exact volume that has reached molar equivalency. Now, my color is blue, but I have a drop hanging, and I'm going to add that drop using a little bit of water, and I can see the color is there, and will the color fade? And just with that little portion of a drop, we actually passed green all the way into yellow, which indicates even a half a drop would have brought us right into our endpoint. Now, while it is also yellow, it is not as yellow perhaps, and it definitely is not a full overshoot like the first trial. So we will place our sample off to the side here, and we will once again zoom the camera in. And in this volume measurement we can see the 14 line at the bottom. And counting upwards from that, but going down by 0.1 each time, we have 13.9, 13.8, and then where the meniscus hits at 13.7. Given that second volume of 13.7 indicates an added volume of 5.3 milliliters, we can see that the first trial was definitely an overshoot, and our third trial now is going to aim for more of the 5 milliliter mark, as I added very quickly, and then slowing it down to the last addition of the 0.3 milliliters. It's important to not try to aim to add a certain volume, but instead, of course, get to the color change, because the end point is what determines the equivalence point of the reaction. So by achieving that color of green, or as our trial there, just slightly past green, we are more certain that we've reached the equivalence point of the reaction. So our third trial, we will add our sample. We will add our titrant, or our indicator. We will again place the flask over the burette neck, the burette tip. And now we will titrate, once again adding in about 5 milliliters without slowing down, and then slowing down for the last bit of the titration. Now to finish the titration, we will slow down, titrating a drop at a time. And I can see the color is starting to change here. I'm getting very, very close to the end point. If I leave it just sit, you can see the yellow stays in the center until I swirl. Perhaps only a few drops more. As that changed almost the entire color, I will use that half a drop and rinse it in, possibly changing the color of the entire solution. Not quite. I'll attempt to do one more half a drop and see if that changes the color of the solution. And again, with only the smallest of additions, we go all the way past the green into the yellow stage, although once again not totally yellow, perhaps more of a yellowish green. And looking at this volume reading, we can see that the meniscus is sitting exactly on 19.0. One of the important aspects of titrating is, of course, measuring your sample with great precision so that there is no chance that the volumes added are actually dependent on this volume of the sample. So once again, we will add in 5 milliliters very quickly and slow down for the last bit of the titration. And slowly add until we reach our endpoint. And in this case, one more time we reach the yellow endpoint. However, we do know that by going one drop at a time, that yellow endpoint has been demonstrating to be fairly close to the endpoint of green. So we'll check the volume. With our volume of titrant, we can calculate the moles of titrant that were used to reach equivalence point. From the moles of titrant, we calculate the moles of sample. Once we have the moles of sample, you go ahead and calculate the concentration of the sample based on the titration data.